Marco and Alberto will be in Chicago next week at Chicago Power BI user group.
Okay.
I think that will be an in-person event, but it will be online as well, virtual. So definitely take a look at that. It will be an AMA, so you can ask questions to both of them.
Nice. So they're gonna join. So it's gonna be in person, but they're gonna join from.
Yeah, so it will be in person, but I think the meeting will be, or the event will be online as well.
Got you. Okay, so this is the Chicago Power BI group, I assume,
Yes.
Sandeep, right?
Yes.
All right. So guys, this is great. Please check it out. And
okay, small correction. I think it's happening this week in a couple of days. It's actually Thursday, the 10th. So it's happening
Thursday
this week. Yeah.
Awesome. All right. And I'm sorry, Sandeep, I want to clarify this. Are they coming on site? They're going to be in person? Okay,
They
wow.
are going to be in person. Yeah.
So they're coming just for the event?
Well, I think they have DAX training here, and I'm guessing they will be here for past community summit as well. So they're just doing that. Yeah.
Wow. Okay, great. Anybody else? Anything else worth mentioning? Yeah, people still want to copy and paste in your browser. Sorry for the inconvenience. So sorry about this, guys. Not sure what happened with the link. Okay, so what else we've got in here? All right, the next thing, real quick, just going through some latest developments in around Power BI. We have deployment pipeline history. I'm not sure how many of you are familiar with this feature, so maybe I can just go ahead and show that real quick from a customer tenant where actually we use this feature. So let's see. All right, so the deployment pipelines in Power BI are a way for us to automate deployment between environments, right? So typically you will have like a development environment, like in this case, you have dev environment, test environment, and production environment, right? 3 environments. Always fun to work with environments, as you know, different layers require different methodology actually to deploy from one environment to another. But as far as Power BI artifacts, deployment pipelines make this somewhat easier. When you create a deployment pipeline, you have to specify your development, test, and production workspace. And then you can just go ahead and select artifacts that you want to deploy and pushing them to test. They always have to be 3 environments for some reason. You cannot just have dev and production. They have to be 3. You don't have to deploy to one of those, I guess, to production, but at least this is how it goes. This is the pipeline. All right, so the new feature here is that now we have a deployment history. So now what we can do here, we can say, okay, we can go back in time and see what was actually published and deployed by who actually, because a pipeline can have multiple administrators. So you can see who ran it the last time, how many items were different that were synchronized. So for example, in this case, we have one foreclosure, one report actually that was synchronized. The previous time it ran, for example, this one here, then no items were changed. But at least we have now the option to understand what happened when the pipeline ran. Typical question that I get here, how about if I want to roll back changes? So you push something to production, ooh, there is a bug. We want to roll it back. Can we do that? No, still can. I hope Microsoft will add that feature at some point, but there is we don't have a feature to roll back changes to these environments. Other than that, I love deployment pipelines because, as you know, the biggest hurdle of moving content from one environment to another is what? To change the connection strings. I got different database servers, different this and that. So the good thing that I like about deployment pipeline, actually, you can go here and specify rules, right? For example, for this data set in here, I actually defined 2 parameters for the server and the database. And so once I have them defined in the pipeline, and once I deploy content, these rules kick in and automatically update connection strings. And you can do that for Power BI reports and also paginated reports as well. So this rules is actually what really makes pipeline useful. All right, so we've got that. Let's go back, see else what we've got in here. For some reason, my virtual desktops don't work so well. Nothing works today. Sorry, guys. Bad day. Bad day for for. All right, so I'm gonna go by some reason I cannot switch my. There we go. Finally. Next thing on the agenda, rollups in Power BI metrics, another new feature. Those of you who are not familiar with this feature, rollups are essentially metrics are a Power BI feature that allows business users to define goals. We had a presentation about that some time ago, actually meeting about it. But essentially the idea here is that I'm a business user. I want to create KPIs. I want to create goals, right? Without knowing too much about reporting or modeling. I don't know this. I just know I have a bunch of reports I have access to. So I want to be able to assemble goals. We call them also metrics or KPIs. You can define the actual, where the actual value is going to come, where the budget value is going to come, for instance. You can do like a tracking and all of this. So the new thing previously, a goal was like a one-liner on the scorecard. So you can define a metrics like revenue. This is where we are. This is where we want to go. And how we are doing in comparison to the goal. But there was no roll-ups. So for instance, what about if I want to see this sliced by customer or by unit or something? I couldn't do that. If I want to do this, I have to actually go to the modeling, to my model, and actually I can define KPIs in there, which actually we had for a while, for a long time in analysis services tabular. So Microsoft kind of a little bit mitigate this with this feature. They allows you actually to roll up roles. So for example, you can have a role for different units, and then you can create a master role, as you can see on this screenshot, where you can say, okay, the submetrics are going to roll up to the main role, and you can define a 4 basically aggregation function. Are they going to sum? Like for example, if you have revenue, do you want to average? Do you want to do a maximum and minimum? So that this is the new feature, the ability to roll submetrics to a high-level metric. Quick measures. I'm going to actually do a demo a little bit of that feature. DAX, difficult to learn. It takes quite a bit of experimenting, frustration, and so forth. So hopefully this feature will make it a little bit easier, but I'm going to show that in a moment. Relationship editing in model view and DAX formula support. All right, so that one actually maybe I can show that real quick. All right, so here we have our favorite AdventureWorks model in here. And as you know, we have a modeling view that actually shows the relationship. For some obscure reason, for a long time until now, you can do some things in the data view, but if you go to relationships view, you can't do them. So now what the new enhancement is that you can change the relationships in here. Instead of deleting and recreating the relationship by drag and drop, you can actually, what you can do, you can just open the properties pane. And when you select a relationship, you can actually make the changes right here in the context of the selected relationship. So that's a new feature. Another new feature that I like is that if you have a measure like this one in here, well, now the formula bar is actually available in Power BI desktop. So I can go ahead and actually change that measure. I can do that in the modeling view. I can do it in the data view. So Microsoft is starting kind of the unification about these views just to make sure that all the features are available it doesn't matter which tab you are on in Power BI desktop. All right, relationship editing, DAX formula support. On the DAX side of things, another feature in here worth mentioning is that there is a feature in preview. You guys know how to enable preview features in Power BI desktop, right? You go to File, Option and Settings, Options, and right here, there is something called Preview Features. So go ahead and enable everything in there to test it out. But one of them, and the one that was recently announced, is horizontal fusion. What is that? That's optimization on the Power BI side of things. In the analysis service, actually tabular, which is the workhorse of Power BI, where under some circumstances, the engine is capable of optimizing the query. So instead of sending multiple subqueries to the storage engine, for example, it kind of can consolidate those in one. So we've seen such optimizations in the past. I'm not sure how much performance gain we're going to live from this horizontal fusion. I'm yet to do my own tests to just to see. We also, it's not clear, what kind of rules, what kind of in which case basically this horizontal fusion will take place. Marco told me that Marco Russo, he's planning an article tomorrow, November 8th, actually, so maybe you can go and check his blog, and
I think he already published today.
he already did it. Okay,
Yeah.
maybe if you can put the link, Sandeep, in the chat window, I think that will be useful for the community to see, those of you who are actually interested in kind of optimizing, to see actually if this is significant and what criteria you have to follow for this optimization to take place. Any questions about this? I have one more thing to show you, but I'm going to do that in a moment. I just want to cover the rest of the slides. Any questions about what we talked about so far? All right, got it. If you're shy, please put your question in the chat window or whatever you've got. The last thing that I want to, okay, so to recap, this meeting is going to be, we have Sandeep Pawar, who actually did us a great presentation the last time about machine learning features, machine learning visualizations in Power BI. We invite him here again to do us another data science related presentation. And next meeting is going to be December 5th, as I mentioned. It's going to be after 2-year break. It's going to be the first one on-site and remote. More details are coming up in the next event on Meetup. So I'm gonna do this one. It's going to be kind of break a little bit out of the Power BI world. I thought that this presentation about budgeting and planning, most organizations actually have the need to do budgeting and planning and forecasting and stuff like this. So just want to show you from the real life a solution that we've built using analysis services and Excel. So that's what the presentation is going to be. And the last thing that I want to show you in here is the last new feature, which is the quick measures, but with a twist. So you guys, maybe you know that instead of, to help you get started with Power BI, Microsoft packages some formulas in what they call quick measures. And you can right click a table and you can say, actually, for some reason, you have to be in the this is the beauty of the, where is the quick measure? It was supposed to be on the right click. Now it's not there. Not sure what happened with the menu in here. But once you go to the quick measure, previously you will just get this. You will get actually the ability to select a quick measure. It has a predefined formula, and that's great. Now you can actually write, you can use Q&A to tell Power BI what kind of measure you want. So for example, here I type year over year change of sales amount. So I have a field called sales amount. I'm just telling the engine that's what I want. And when I click generate, it kind of tells me what the formula is. And if I'm happy with the formula, I can go ahead and add it to the model. And once I add it to the model, I can see what the formula, I see what they do. If I want, I can change it from that point. From that point, it just becomes like a regular measure. So another use of Q&A, give it a try. Again, this is a preview feature. You have to go and enable it, the suggested measure feature, and just see how smart it is. Would it would it understand what are you asking, or it's going to be lost? So give it a try. Provide feedback. With that said, I want to apologize one more for the hiccup this meeting, for the missing the meetup link. Not sure what happened, but we managed to salvage that meeting, and there's going to be a recording in there as well. So with that said, Andy, please, the floor is yours. Go ahead.
Thank you. Go ahead, share my screen. And if you can just confirm, Theo, you can see my screen.
I can see your screen just fine, sir.
Perfect. Thank you so much. Okay, so thank you, Theo. Thank you, Damu, John, everybody at the Atlanta Power BI user group. As Theo mentioned, this is my second time joining you guys. So very glad to be here, and thanks for inviting me again. So very happy to be here. We have a loaded session today, and the topic is data science for Power BI developers. And I've been wanting to do this session for a very, very long time, just never had a time to present it. I have presented before on some of the AI and machine learning topics before, some machine learning or AI visuals in Power BI. I've talked about Azure ML, and whenever I present this topic, the question always comes up, okay, but how do we get started with this? So when Theo asked me, do you want to present again? This is the topic that I thought I would cover. So thank you for again the opportunity for to give to present this topic here. The agenda for today is I will mostly go over why you should care about data science. This session is not about creating machine learning solutions or teaching you how to create machine learning solutions. We will not go over into the nitty-gritties of different algorithms, Python versus R, statistics, and all that different stuff. Each of the bullet points or each of the things that I'm going to talk about that can very well take 2 days for each to talk about. My real motivation here is after this presentation, you should at least have high level understanding as to you as a Power BI developer, why you should learn data science, how you can incorporate data science into your workflow, and what exactly data science mean. If you ask 10 different data scientists, you'll probably get 10 different answers to that question. So you as a Power BI developer, now in my role as a senior Power BI architect here at Hitachi Solutions, I work on Power BI projects mostly. In the past, I've worked on both Power BI and data science. And whenever I get my hands on Power BI project and any data, I start using data science, and I'll show you how I incorporate those tools and techniques into my Power BI workflow. The other motivation here is to equip you to collaborate effectively with other data scientists. You may not create data science solutions or machine learning solutions, but if you work with other data scientists, hopefully at the end of this presentation, you will have good enough understanding as to what the data scientist does, and more importantly, how you can collaborate with them, and at the same time, how you can um, avoid some of the pitfalls that even though they are experienced data scientists, that some of the pitfalls that they can fall into, and how you can avoid that as one of their collaborators. Now, You may have seen this before. This is the blind man and the elephant parable, right? If you are and the story goes that there are 5, 10 different blind men, and then they go and touch an elephant, and depending on what part of the elephant they touch and their experience, they will give a different answers, right? So somebody touching the spear, he might say, or touching the tusk, might say it's a spear. Somebody touching the tail might say it's a rope. But none of them know exactly that it's an elephant. And why is that? Because they have their own experience, they have their own expertise, they have their own um, background, and depending on who you are, it can be a different answer. And that happens with the data as well. We have all these different personas who access and use the data. A database administrator would look at the data differently than a data scientist, than a BI developer, than an analyst, and a business user. So depending on who you talk to, they will give you a different perspective of the data. So how does that fit into this overall picture as to why we want to learn data science? So let me start with a demo before we get into the concepts of data science. At any point, if you have any questions, please let me know. And Theo, please feel free to interrupt me at any point if you have any questions.
Absolutely.
What I'm going to do is simplify things as much as I can. Um, there are a lot of technical and statistical concepts when you're working with data science. What I'm going to try to do is simplify them so that you can get intuitive understanding of these concepts, and then you can later on, if you find that this is something you're interested in, I'll give you some of the resources that I've used so that you can learn more about this. So let's start with a Power BI report. So I challenged myself that hey, instead of using a toy data set like Titanic or Penguin data set or Cars data set that are typically shown in any data science and machine learning related tutorial or a workshop, to start with an existing Power BI report. So I pulled this from the Power BI GitHub. And this is a Power BI sample that's on Power BI's website. And I challenged myself to spend an hour and then see what I can get out of this report and how I can use data science on top of this report so that I can show you really how I would go about doing this thing. And the idea here is when I am working on a Power BI report, my mind directly goes to the data sets, data set optimization, the visuals, DAX, creating relationships, 1,000 different things that go in operationalizing a data, and then all the governance part and everything. Whereas when I'm working on working in a data science solution, I think about the data differently. And that's essentially what the difference between a data scientist and a BI developer is going to be. So with this demo, first what I want to do is establish that how I would do things differently if I have an existing report and if I start using the data science principles. This is a Contoso data set, very standard stuff. So we have sales data. Let me go here. So we have sales data, product, and somewhat a star schema here. And there are a number of different tabs here at the bottom. Very beautiful looking. I think Miguel and Chris from Power BI team, they created this. And very standard stuff. So we have net sales, and then we have returns, we have return rate, and things like that. And the idea here is that user would go here and interact with the report and get some understanding of the data. So one of the things that's in here that caught my attention is the return rate, for example. And the idea being here that for this company, for Contoso, uh, customers purchase the product and some of the customers, they return the product. And that affects the overall forecast, that affects the overall state of the company, the net sales of the company. And a what if scenario is created over here where the user can actually go and then they can create a what if scenario. And uh, the goal here is that not to create a static report. They should be able to interact with the report and create maybe some sort of scenario analysis so that it becomes more dynamic. Very standard stuff again. In the table over here, we have net sales for each of the stores, and then what the forecast looks like, and that takes into account the overall return rate. On the right-hand side, it's just a forecast of these products that are selected for this given time period. So what I did was I just downloaded this data as is from this report, and I started working and applying some of the data science principle on top of this. When I'm creating this, what I usually do is I start using a Jupyter notebook. Now, if you are not familiar with Jupyter notebook or Python or R or SAS, SPSS, or be it anything, don't freak out. First question and the very first thing that most beginners with the data science, what they get caught up in is thinking that you have to learn all of these different things, which is true, you do. But what I want you to do for this session is completely forget about the tools that I'm using and completely forget about the language that I'm using. Just focus on why I'm doing, and then later on you can figure out how I'm doing it. Okay. So what I did was I just imported that data using Python into the Jupyter notebook. We have the exact same data. And what I did in here is I first created a weekly summary of that data. So there are, I think, about 200,000 rows, so not significantly large data set. So I started started with this sold weekly. So that gives me the products that were sold and the products that were returned by the week of the year. Okay. So I created that, and then I joined it together to create a weekly return rate, which essentially is nothing but just the product division between the return. And then let me zoom in a little bit. You can see it better. A division between the return divided by the sold products. And overall, I get a return rate of 39%. And if I get to look at the average, it's 38%. And if I look at the median, it's 35%. So that's number one. Okay. So there is a little bit of difference between the two, 39% and 35%. So just keep that in mind. Then I looked at the distribution of the returns. And this is what the distribution of the returns looks like. So if I go up here, remember I have the week and then I have the returned amount, right? And all I'm doing is for the overall, what does that return rate look like? The black line here shows that flat 35%. Um, yeah, black 35% overall. And then this is the overall return look like. The distribution looks like. Now, there are two things that I would like to point your attention to. The first is the shape of this distribution. I see two different peaks here, and at the same time, it doesn't look like your typical bell-shaped curve, right? If it was a bell-shaped curve, it would look perfectly symmetric. So it is not symmetric, and a bell-shaped curve will have one, I guess, peak. In this case, we have two different peaks. So that's observation number 3. So first observation was the difference between mean and the median. Second observation was the shape of the curve, the distribution of the overall returns. And third observation is that we have two different peaks. So that begs the question, why do we have this kind of a distribution? Why is it not symmetric? Does it matter if it is symmetric? Two, why do we have two different peaks? Okay, so let's dig that a little bit into that. So what I did next was my hypothesis was maybe it could be related because I'm looking at all the stores. Okay, maybe because we have different stores and all these different stores have different distributions of the returns. Stay with me here, okay? Don't get too confused by what distribution mean and all that. I will explain that, okay, and why that matters. Just stay with me here and follow the process. If I draw the median line, so this is the 35% median line. If we look on the left-hand side of the median line, I see this is a box plot. On each of the box plot, this line here, that indicates where the median is for that store. So if I look, for example, this store called Salvas, this shows me what is the overall distribution of the return look like, the weekly distributions look like. My median for that store is around 22%, right? It's on the left-hand side of this median line. And then there are some stores that have median that is on the right-hand side. So all these different stores. So that could potentially explain that maybe we have two different types of stores, one that have the overall median, the average, that is very, very high and then very, very low. That's one possible explanation. Now let's again dig deeper, slightly more into it. So what I did was this is the overall distribution. What if I break down that distribution by the store, right? This was the aggregate for considering all the stores. What if I break it down by different stores? And we get the same picture. So there are stores that are on the left-hand side, and then there are on the right-hand side. Another thing to notice here, like what we did earlier, is not all the stores follow this exact same aggregate pattern. That is, they are skewed to the right, meaning they have hump that's on the left-hand side of maybe where the median would be, and they have two different peaks. If I look at all the different stores, we have some stores that have peak here and then further down here. There are a couple of stores that have two peaks, but their highest peak is on the right-hand side and then low peak on the left-hand side. And then there are stores that have distribution that looks like this, that is completely flat in the middle and then tapering on the left-hand side and the right-hand side. So what caught my attention was this store over here, okay, this store. So let's look into that. Um, So I look into that, again, follows that distribution. So maybe let me look at the products for that one store. Okay, so I started looking at one store and let me break that distribution down further for that one particular store by products. So now what we're looking at is the overall percentage return by that Salva store but for different products. So now again, you will notice here that the distribution for each of the products is also different. Why would that matter? And why am I showing you all of this? Because if I plot the returned quantity or the returned amount versus the sold amount, you will see here that some patterns start to emerge. That maybe there are some weeks or there are some stores that are over here, there are some that are over here, and then there are some that are just completely outliers, just floating around in the space. Okay. If I take a log of that, and I will explain that a little bit why, because we have overall data that's very, very spread out. So if I go up here, you will notice that all these small diamonds over here, these are nothing but outliers. Okay. And so the overall data is highly spread out. So let me next go into the percentage return by week. Okay, so we looked at the overall distribution of the return rate by stores first. Then I looked at the distribution of the return by product for one store. Then I'm going to look at the overall distribution of the percentage return by week. If I aggregate all the stores together, the distribution this is just a timeline. So on the right, on the x-axis, we have week of the year, and then on the y-axis is the actual return for that week. So interestingly, what I notice here that at the beginning of the year, we have low return rate at an aggregate level. Then maybe around March or April or so, the return rates go high up and then significantly drop down and then picks up again. What if I further break it down by stores? If I do it by the week, I notice again that there is just some band around it. Okay. And in statistics, that band represents the overall distribution again. If I break it down further by the store, you will right away notice that there are some stores that beginning of the year, their return rate is small. And then there are some stores, their beginning rate is very high. And then they all go down, then go up, and then go down. Even these stores over here they start small, go up, and then go down. Now, the reason why I am showing you all of this is because if I had a Power BI report that I just showed you, would you be able to get that sort of an insight from just if you created a Power BI data set? If you notice here, while I was going through this example, I used only two statistical terms. First was the mean median, so that is just the point estimates. And the second was the distribution. And this is where the difference between a BI analyst or a BI developer or a data analyst and a data scientist lies. A data scientist will look at the uncertainty in the data, overall distribution of the data, and dig deeper into the data. Whereas when you are working as a Power BI developer, you are more interested in at an aggregate level what has happened. Give me the overall summary. Give me the overall statistics, like what is the mean, what is the average, what are the rolling means, what are the sums, the count, the distinct counts, and things like that. And when you are doing that, that washes away the underlying signal that resides in the data. And that signal comes from the distribution. So when you are working as a data scientist, and I think that in part has to do with the tools that are available in Power BI as well. This is not something that you can easily do in Power BI. And it's very surprising and very unfortunate that Power BI does not have a way to visualize distributions. Not that you would, and if this kind of a thing was available in Power BI, I'm pretty sure that everyone would start using that. But it's just the limitation of the tool that you are not able to do that. Now, does that have an implication on the Power BI report that I just saw? So if I was working on this Power BI report, if I had developed this, and how would I use this insight into my Power BI report? Would that have changed here? Absolutely. The first thing that in this Power BI report that I would change is this what if scenario is giving me the ability to change the percentage, right? But let's pause here for a moment and think about the implications of that. What I'm saying with this what if scenario is if I change the return rate from 10% to, let's say, let's go all the way up to 52%, all of those numbers going from 1% to whatever this the highest range is 60%, all of them have equal probability of occurring. And we just saw with the distribution, that's not really the case. I drew this line at this. So when we are using that what if scenario, what we are saying is that this percentage return rate, this is the percentage, right? All these numbers have equal probability of happening. So is that the case? Looking at this data, we know that's not really the case. What is going to happen is the Power BI user, the user who's going to actually use the report, they should actually use maybe something that's in between this because that's more likely to happen because that's where the peak is. So maybe between 15% to 25%, and then again maybe between 42% and 50%. But that's not all. We also saw that the distribution changes with the type of the store. So not only that, this what if scenario that's created over here, that should not be uniform distribution like this, but that distribution should be different for each of the stores. And the Power BI user should know that. Now you might ask, well, Sandeep, that's all nice and good, but how would you actually implement that in Power BI? Not that easy to do it. So if you go to my blog at powerbi.com, and I have been planning to write a blog on this, but let's go to one of the blogs that I have written about DAX formulae for creating statistical distributions. And this is what we do when we use that what if scenario. All the range that we have has equal probability of happening, but we can actually assign a distribution to the what if scenario that looks somewhat similar to what the distribution that we just saw. So the way I would change this Power BI report then is to first highlight and tell my business users that, hey, the distributions are different for those return rates. And for this store, you cannot use 15% because that's unrealistic. Maybe you should use this and this range at the very least. And then they would be able to get more practical insights from this report. Let me go back here. And as I showed, as just mentioned, that when I was going through this Jupyter notebook, I did not use a whole lot of statistics. I used just the basic common sense and I looked at the overall distribution. I was able to incorporate or I will be able to incorporate the findings that I got out of my analysis in the Jupyter notebook into Power BI. I did not create any output from the analysis that I did. All I got was the insights from it. And this is where I think the majority of the confusion comes from for most of the Power BI developers. To think that when you are creating a data science solution, you have to create some sort of a prediction, you have to create some sort of an output, and then use that output into Power BI. That's not really the case. What I call this as enriching your Power BI reports with the insights that you get out of the data science workflow that we just looked at. You don't have to use a ton of different statistics, fancy algorithms, and have to know a ton of different statistical concepts. What you have to do is use a different approach to looking at the data. Now, like I said, unfortunately, Power BI is not a tool where you can use that approach. Perhaps Excel, you can use analyze in Excel because Excel can create distributions. So maybe you create a data set, publish that to service, and then use Excel to actually create these distributions, or maybe create all these different box plots. Excel has box plots too, and start using that so you can get more insights into that. And then once you have that, you can either incorporate those into your Power BI report or bring it to your user's attention that, hey, what the summary that you're looking at, there is more to the data than just the summaries that I'm showing in the report. And maybe that might change the way they look at the overall data. So when I talk about data science and using data science as a Power BI developer, what I want you to understand is that um, what you can get out of data science as a Power BI developer is actually identifying the structure and patterns in the data so that you can enrich your Power BI reports or supplement your Power BI reports with those data sets, identifying overall trends in the data, which are not very easy to do in Power BI. Because if you look at the distributions and all of this different things that I did, I call this as a free flow thinking, that created something, I looked at the distribution, then I saw something, I made an observation, then I went to the next step as to figure out why that is occurring, and then that triggered the next step, and then I kept going one step down. When you are working with Power BI, the main limitation is the DAX, right? If I wanted to do a similar thing, I would have to spend one day just to figure out the DAX to get that part working, and then go from there. So, which is a limiting factor in Power BI. So when you are thinking about using these tools, I would encourage you to think about how you can use Excel. If you're familiar with Python, then maybe figure out how you can do that in Python. There are a lot of GUI tools as well, that I will mention. The third thing that you want to do when you are using data science, your goal is generalization. We'll talk about that. And the last one is the predictions, being able to create predictive analytics, which is what truly most people think about when they think about data science or machine learning. The common tasks that are involved in, other than just exploratory data analysis that we just saw, looking at the distribution, so that would be the exploratory data analysis. The common task as a data scientist, what you would do, regression, which would be looking at or making predictions or finding associations among different features that you have in your data, to find association in them. For a numerical quantity, classification would be predicting a categorical data, and will have examples of all of these different things. Clustering, which would be, you can think about that as segmentation, and then time series analysis. So let's start with regression. And you may or may not be familiar with the term. So let's define what a regression means. Regression is nothing but if you have a quantity that is a numerical quantity, and you want to be able to find association of that numerical quantity with another uh, uh, columns that you have in the data, or being able to predict that numerical quantity. So what is an example of that? So let me go back to the Jupyter notebook where I started all of this. So in this case, we have, in this data set, we have customer dimension as well. And these customers have age as the demographic information. And what we want to be able to understand is there any relationship between the amount that that customer spends and their age? So what I did in this case is I just did a group by. So if I zoom in here, I just did a group by on the age by the amount and just took the sum of that and then created a scatter plot. If you notice in this, I have age bucket. So I have 15 and then 20 age bucket, 25, and then in between, I took some liberty to modify the data a little bit to for demo purposes, and then the overall sum of the overall amount. What we notice over here is that if I draw a line that goes through the most data points, is that it will go like this. And what we want to do with the regression, like I said, is first is identifying association. And that association is what happens as the age changes to the overall amount. And the answer to that would be that as the age increases, the amount overall amount goes down. Okay. And so the direction here is negative, meaning we have a negative correlation between age and the amount. And the second is overall slope of this line. If it was going something like this, then we would be saying that, hey, if the person is 35 years, then he would be spending significantly less than a person who is 20 years old. But in this case, what we have is the 20 is spending just a tad bit more than person who is 35 years old. So we notice two things here. First is the overall direction of the relationship, which is negative. And then two, what is the overall gradient of that, which is not so much. So what we would say is, again, going back to what the association between the two is negative. As a Power BI developer, you would not be looking at that kind of association, right? We would again create some summary statistic, but not definitely look at the overall association. The major pitfall, and you will see this saying me over and over again during this presentation, is major pitfall that people fall into when they create this regression line is thinking that correlation is equal to causation. And what that means, and you might have heard about this many times as well, that correlation is not does not mean causation. What does that mean in practical terms? What we are saying here is that as age increases, the amount goes down. But that does not necessarily mean that if I have a person who is 35 years old, if I go back 5 years, that person would be spending a little bit less amount. This is an overall average effect. That it does not mean that if I take a person who is 35 years and if I take him back by some time machine 5 years back, that person, that person would be spending less, overall less in on the contours of product. And th- th- uh, so when you are working with a data scientist and then they create this regression, and if that is the conclusion that they make, then you should absolutely stop them and then repeat this line that correlation does not mean causation. There are ways to ensure that. So you might have heard about, or you probably are aware of the drug trials, right? In drug trials, what we do, a company creates drugs, they find maybe 10,000 people who they give a placebo, so which does not do anything to them. And then they find another 10,000 people who they give the drug to, and then they compare the two. Is there any difference between the two? And that tells them that yes, there is a significant difference compared to the placebo group. And those are called randomized controlled trials. If we want to create that sort of that is not a correlation, that is a causation. um, if we want to come to that sort of a conclusion and want to definitively say that age has an effect on the amount, then we would have to go to that level of experimentation to say that age definitely has an effect on the amount that the person is spending. So how would you use something like this in your Power BI report? Well, again, now this is not something that you can use directly, but maybe this is something that you should bring to your users' attention that, hey, what I'm seeing is some sort of a relation between the two. But if you are more statistically inclined, you will also tell them it is not significant. In this case, for example, if I look at the overall correlation between the two, it's minus 25%, so not significant. A correlation of 1 or minus 1 is very high. Correlation of 0 is nothing, and we are closer to 0. And then at the same time, not all the data points are within this shaded area, which again tells them there is not a whole lot going on. So if they were come to me, I would tell them that I would tell the user that age has some correlation or association with the amount that our customers are spending, but it is not significant that we should look into it further. Now, as I was going through this, what we just did is it's very tempting to go back here and then say that if I go back here, it's very tempting to use this as a prediction to say that if the customer's age is 30, then go up and then go to the left and then say that yeah, that person will be spending $80,000 overall in a year. Because we are using a numerical quantity that's called regression, but we are using a prediction. Now, when you are working with a data scientist, we can do this exact same thing in Power BI as well. So let me digress that a little bit here. and we go to regression. If I take this exact same thing that I did, I can plot it here and go to visualization, and then go to the analytics pane over here. Okay. And then expand that a little bit. Why is not, oh, I have to first create a scatter plot between the two. So I'll take x-axis goes on the y, and this goes on over here. And then we can create a trend line. So if I turn this on, it gives me a nice trend line. So you can basically do this in Power BI as well. But notice that the Power BI does not give you any sort of indication as to assess if this is good or bad. And in you will often see data scientists put some numbers on top of this to say if this is good or bad. And one of those numbers, for example, is R squared that you might have heard about. That the R squared number for this correlation or this model is something 90% or 20% and 25% and things like that. And what they mean by that, they are using this as a prediction to say we are going from using age as the predictor to explain what the amount will be. And that's the part, the prediction part is where machine learning comes in. So let me take a moment here to explain what machine learning is all about, or predictive analytics as well. In this case, I had a fact table which had all the transaction. I had a customer table that had all the customer details and mashed them two together to create a denormalized table, a flat table. And I started with that and I created this model. And what that means is when I looked at this customer data, I took for this customer, there are 100 different things that I could have possibly looked at, right? I could have looked at their age. I could have looked at their gender. I could have looked at their maybe net income. I could have looked at where they live, what they do, and all those sorts of things. I only looked at age, but I could have very easily taken, if I had all of those things in my dimension table, I could have pulled all of those things. So I took a slice of that, right? And then I created a machine learning model. And what that means is I started with all of this data, and what I wanted to predict was the overall amount. And you can think of this as a mathematical equation that I have the x in this case is my denormalized table. Yeah. Is there a question? Okay. So what I started off with this denormalized table. Okay. And I told this algorithm to go figure out that is there any correlation between this X and the prediction, which is the overall amount. And it went and then created this some sort of a mathematical model, which is what this F represents. So F is nothing but that I am creating a model that gives me all the inputs, your denormalized input, into feed it into it, and then spit out some sort of a variable that tells me if what that quantity is going to be. And that's what machine learning is all about. You take something into it, you run some algorithm on top of that, and then you spit out a prediction that you are interested in, and that forms your overall machine learning model. Now, there is a reason why I only showed a small window here and not the entire table. And I have two different arrows that are feeding into this. And the reason for that is if you take one thing out of this overall session is that whenever you are working with data science, what you have to realize is that it is an approximate science. It is not definitive. Because, like I said earlier, when you are creating these machine learning models, you do not know everything. Maybe in my dimension table, I have some attributes that are related to the customer, but not everything. I don't know if they are a parent. I don't know if they are grandparents. I don't know if they're grand, um, a grandfather, grandmother, or whatever, where they live, what their zip code is, and all that sort of stuff, because that could have very well explained or improved my overall model significantly. And the reason why I'm showing this small table is because whenever you create these machine learning model, you cannot possibly know everything. You're always working with some sample of the data. So you can say, I know, have some data, but you are almost always 100% of the times, you're always working with some sample of the data. And this model that is generated, that your data scientist is going to create, is based on that some sample of the data, which means that if my data changes, my model is going to change. So always keep this slide in mind, that whenever somebody, a data scientist, comes to you, or you work on any sort of data science project, the model is always tied to the data generation process, always tied to some sort of the data. If that data changes, then your model is also going to change. And what you have to keep in mind, the model is always guilty until proven innocent, because the model is always going to be wrong. Our goal is to make sure that the model is good enough so that it represents that's overall what the true data looks like. So if you think of this as maybe some sort of a ground truth, that I have some sort of a function like this, my model is going to be an approximation of what that actual thing is going to look like. So the pitfalls that you want to avoid, and the reason why I'm telling you this early on instead of telling you at the end, is because when a data scientist comes to you, or when you are working on a data science project, the temptation is to extend this model to and apply it to everything, which is not going to be correct. What you want to keep in mind is that that model, or the insights that you are going to get, are always tied to some sort of data. Okay. Predictions, when you create predictions, those correlations that are created does not mean causation, that we just talked about. The model that we are creating is tied to that data generation process. Meaning, for example, if the we just went through a pandemic, right? That could have very much affected their buying behavior, right? If I took the data and if I only work with the data that was generated during uh, the pandemic, or maybe even before the pandemic, that model would not be applicable during the pandemic. And now we are through the pandemic. The model that was created during the pandemic would not be applicable now, after the pandemic, and then so on and so forth, right? So when you are working with any data science project, what you have to keep in mind is what your data assumptions are. A data scientist will also tell you that my model is 90% accurate, 95% accurate, 100% accurate, whatever it is. But an accurate model does not necessarily mean a correct model. And an example of that is, in 1400s or 1500s, whenever Copernicus and Ptolemy, they were the two, I guess, scientists, and they created this whole model of how the our solar system works. Copernicus said that sun is at the center of our solar system, and then he predicted how the other planets move. Ptolemy, on the other hand, he has a different approach, and he said, no, Earth is at the center, and Sun is all actually revolving us. And then they came up with exact calculations. They were able to, both of them, they were able to predict how Saturn, for example, changes its position related to Earth. But we obviously know which one of these two models is correct, right? So if somebody says their model is correct, and their predictions are correct, that doesn't necessarily mean it is correct. Extrapolation, always be aware of the extrapolation. You have to use, what extrapolation means is that if, what I was showing earlier here, it doesn't mean that if I extend this line out, that and if I go to the age 100, that person is going to spend zero amount, right? That's just not going to be true. So you have to always keep in mind, if a data scientist talks to you and he says that you have a model, you have to be aware that you cannot extrapolate that model significantly. Uh, so I will talk about this if we have enough time at the end of the presentation. But the next one that I want to talk about is the classification. So first we talked about the overall regression. Regression meaning you want to predict or find an association of a numerical variable. And then classification is actually predicting the categorical output. Okay, and what I mean by categorical output is, let me go back to this over here again. In our data, we have customers who are buying the product, and then there are customers who, after a while, are returning the product. And what we want to be able to do is predict if um, if somebody purchases a product, what is the probability that they will return that product? Okay. So with classification, what we can do is predict that, and that's actually available in Power BI as well. So you've heard about key influencer, right? So what I can do is I can again denormalize, and what I did was I took the ID, I took the amount the customer spends, the category of the product, the price range, product, the store they bought it from, and all of that. I put it into the key influencer visual, and I said that, hey, tell me what influences them to return the product, right? And when I click on that, it gives me some sort of an output. Let me click on this, and it gives me some sort of an output when the product is category, when the product is stream, and so on and so forth. So all these different things, the regression, the classification that I'm talking about, it's available in Power BI. But we can, if you are a data scientist or if you learn data science, what you can do is improve this even further. Because notice when Power BI creates something like this, which your user will find extremely helpful to understand that who is actually returning our product. Power BI does not tell you how good it is. It does not let you choose what kind of algorithm that you can apply to this. And this is where your data scientist really can help you. So what they can do is they can take this into Python or R or any tool that they have available, and then apply different algorithms on top of that. So now in this case, what this is telling me is that if I create a classification algorithm on top of this to say, if again, classification, meaning if I have data like this, so if the data is distributed like this, and if this is people who return the product, and these are the people who did not return the product, what is that classification? Where does that boundary lie where I can definitely say these are the people who will return and these are the people who will not return? Okay. So with that, with machine learning, we can figure that out. And what this is telling me is it is almost 91% accurate, and we are able to use machine learning to predict who those customers will be. We can take that, or a data scientist can take that, and then he can import those into Power BI and create a report on top of that. So how would, as a Power BI developer, how would you use that? Well, you can create a page here where you can have something that's actionable, that now I know which product category it's most tied to. So which in this case would be, maybe it's something like the product that would be most returned would be this stream, whatever that is, publisher, exchange, and access, and SharePoint. These are more likely to be returned. It also depends on the month in which they return it and the store that they bought it from. So maybe you can create a Power Apps where if when the data comes in, maybe you can create some sort of a mailer or an email where an email goes out to those customers to give them, offer them some sort of a promotion, or do something along those lines so that they are less likely to return the product. A machine learning solution or a data science solution should always be tied to a business outcome. And an example of that is if I open this Power BI report, if I go to the key influencer visual that's actually available in here, let me go right here. And there's a key influencer visual that is right over here. So let me go here and then click on this. Very nice report, but let's zoom in a little bit here, and then you will see that what influences the returns for the customers to be male or female. So when I go for male and then female, it changes the output, right? But again, let's pause here for a minute and think about, is this something that our users will find even helpful? Because this is who walks into the store, a male or female. I cannot I cannot control that. Okay. I understand the intention behind this, that why it was created. That maybe what the developers what they wanted to get out of this was, okay, tell me if a female goes into the store and buys something, what happens? And what happens is that they are usually between 26 to 30, 15 to 20, and they typically buy products that are in the category Power Platform. But that implies causation. What we are saying is that if I go from male to female, who's going to come in, they're more likely to purchase a product that is Power Platform. And like I said earlier, we don't want any machine learning solution, or especially the predictive machine learning solution, to be used as causation. We cannot control who walks into the store. So absolutely be aware of that. These are things that even the most experienced data scientists and Power BI developers alike, they make to where they randomly put something in, they get the output and think that we have created something that's really cool and then use it. So this is a good example of how not to use data science, because we cannot control, right, any of these different things. Let me go over here. The next one is the clustering. So I see that we have only a few more minutes left here. So I will go into this a little bit. So what clustering means is a segmentation, meaning I have the data and then we can segment the data in different ways. And we can do this heuristically, meaning we can just say that, okay, the data that's above a median is this and the data below is this, or I can create the median on both X and Y and then create categories, create maybe bridge tables to say, okay, if this is in this category, it's high, high, low, low, and things like that. Whereas with machine learning, what we can actually do is figure out where the patterns are. So like what I showed earlier, we can see from this, for example, that when I plotted sold and return, there is a pocket of customers or stores that are over here, and then there are some stores that are over here, and they behave differently. And how you can use this in your Power BI report is if I created a clustering, and in fact, you can do clustering in Power BI. So let's go over here and I can do this exact same clustering in Power BI as well. So when I plot this data, you can just go to the click on the three dots and then click on automatically find clusters, and it will let you create the clusters and you can find the clusters. And the way you would use that is to figure out how one store is different from the other store. And we can create this cluster, which is more dynamic instead of saying use above the median or below the median. This is more dynamic, and then you can give this more insight to your business users. We won't go into the details how exactly this works. I have actually presented before on how to do clustering in Power BI. So check out my blog where you will learn more about it. And the last one is a time series analysis, where again, the goal is to find the structure in the data, create forecast, and the anomaly detection. So let's go over to Power BI because this is something that's available in Power BI, right? So let me go over here and go to net sales and then look at, where was it? The return rate, maybe over here, right? And let's look at this one. And what this is showing is that it's creating a Power BI or it's creating a forecast, and then we have some sort of a forecast in here. The mistake that the Power BI developer in this case made was first not figuring out if the data is seasonal or not, which we did because we used data science principles to figure out that, yeah, there is some seasonality in this data. So when we looked at this, we can clearly see that at the beginning of the year, the returns are low, it goes up and then goes down. The Power BI developer in this case did not know data science, so they used this as is. And then on top of that, they created this. If I open this in this case, and then go to the forecast, and then if you see the forecast length in this case is 5. So what they did was they used a fork to say that the seasonality in this, or rather the seasonality in this case, is they used a seasonality of 5. Because we use data science and looked at the data, we know that's not the case. We clearly know here that there is a weekly seasonality. So which means that first, this data should have been aggregated at the weekly level, and then we should have used a weekly seasonality in this case. Not only that, if uh, if if you had studied time series forecasting and time series analysis, you wouldn't actually be using this type of a forecast because there is not enough data. As I showed earlier, we have only half worth of year of data. So there is not enough data for us to create even forecast. And that's the reason why you should be learning data science or statistics, so that you do not make these mistakes. And the mistakes that are typically made when you are working with data science professionals are like what I showed earlier here with the pitfalls that we want to avoid. That the first, correlation not equal to causation, and we do not want to extrapolate the data. In this case, the data was extrapolated incorrectly, which led to the wrong, which would lead to wrong forecasts, and then we would mislead or give wrong information to our Power BI users. When somebody gives you or creates a prediction, or create a machine learning solution and gives it to that, always ask them that where would this model fail. Okay, so if somebody created a forecast and gave you the forecast, you should ask them when will this forecast fail. What are the modeling assumptions in that case? Because like I showed earlier, any machine learning solution or in a data science solution that you create, it is always tied to some sort of a data. And what are those data assumptions, right? And then what is the error metric that was used? So anything that was created earlier, for example, with the forecast that was created, how good is this? And they will give you the answer, and then you have to probe that answer further as to how confident you are, what are the uncertainties, where would this model fail, and so on and so forth. I know that's a lot to chew on and understand, but hopefully with this session, what hopefully what you got out of this is how you can use data science in Power BI. Uh, there is a lot to learn. Where I would begin is first start using the tools that are available in Power BI. Okay, understand them very well, understand where you can use them, understand where they do not work. And then if you think that you need to learn data science, if this is something that want to understand more, then I would go and then use some of the resources that I'm going to show you, which is you have this now. These two books are completely free. This book is not, but I would highly recommend it. It is something that a business analyst or data analyst would completely follow, and some of the concept that we just talked about. So my recommendations to you would be to start with the AI and ML visuals that are available in Power BI. Get familiarized with those first. Second, do not think that you have to know all the statistical concepts. the difference between a data scientist and a Power BI developer is the way they approach the data. So going back to the elephant example that I gave you earlier, they are looking at the same data, but they are looking at it from a different lens, different perspective. So s- y- y- think about that a little bit more. Definitely look at my blog where I've presented these approaches before. Focus on the use cases and don't get too much caught up into the algorithms and the overall, whether I should use Python or R. Figure out first what the use cases are, and then you will automatically figure out what these or different algorithms mean. And always remember that the goal is not to create the most sophisticated model. In many cases, what you create with Power BI is just going to be as good as if you were to use some machine learning solutions. But first, you have to figure out what that baseline is. It could be a completely naive solution, like maybe if and then statements in Excel, and it might very well work for you, but you first have to create that baseline, and then from that baseline, you would start building a more sophisticated solution if the need be, and it has to satisfy your overall business requirements. Okay. Now, I completely understand this was a whole lot that we went over, but hopefully that just gives you good enough understanding as to what all entails if you do want to pursue data science and if you want to incorporate data science into your Power BI reports. Okay, so let me just pause here for a moment and bring this up so that you can ask me questions if there are any.
Sure, Sandeep. Awesome. This was great. We have a few questions that I want to ask you. I want to start with a while back, Fernando was asking, you show how to use Jupyter Notebook to do distribution analysis. So I guess the question was, can I use the same approach to analyze distribution in Microsoft Synapse?
Absolutely.
And yeah, it's just a
Mhm.
data source. That's what I thought, but
Yeah.
maybe
Yeah. In Synapse,
if
you
I'm
have Synapse notebooks, right? So you can do exactly the same thing. In fact, Synapse is what I use. So you would connect to the data, your Parquet file, Delta file, whatever the source is, and just start plotting and looking at the data differently. Um, yeah,
awesome. And Pranan had an interesting question. So he wanted to know if how do you handle missing data? And specifically, he's asking, um, does Power BI provide any tools, functions to apply various imputation methods, or do we have to use imputation methods provided by Python or R?
okay. Yeah, good question. There are two answers to that question. So the first one I will talk about in what I said earlier, that you always have to remember where you start with the data. Okay. Whatever algorithm you use to impute your missing values, impute meaning just to fill your missing values, that is going to be the assumption in your data, assumption in your model. So what I mean by that is, let's say, for example, you're working with sensor data. I've worked with sensor data before, and you want to create some sort of a solution on top of that. You take the sensor data, and then maybe it records something, records something every second, right? Maybe at time t equal to 0, you have some reading. Maybe the sensor data went bad, or the sensor went bad, and now after 5 seconds, you have some other reading, right? Now, in between, you don't have anything. Now, a good approach in that case, because it's a sensor, we can approximate that maybe the values in between, because the data is not going to change significantly. You can just use standard interpolation. You can just use the same values and do that. In in data science solutions, what you use is mean imputation or median imputation. Meaning, if you have a customer, for example, that we looked at, the age, for example, if the age is missing for some customers. A valid approach would be to say, I will take a median of all the customers that I have, maybe in that geographical area, and then use that value. And that would be a good enough approach. But what you have to keep in mind is that that assumption, whatever assumption that you are making, is tied to that model. If that customer changes or goes to another region, lives in another region, now maybe the median changes and now your predictions are not going to be correct. Okay. So the reason for saying that is because again, you have always have to keep in mind that whatever you create is tied to that data generation process and the modeling assumption. To answer your second question as to how you can do that, so I've actually written a blog on this exact topic on imputing missing values, and there are statistical ways of imputing missing values, so missing value analysis and imputation using Azure ML. It's a very heavy topic. Can you do it in Power BI? You absolutely can. So there is a in Power BI you have a backfill and forward fill, right? You can do that. When you are creating a machine learning model, on the other hand, that won't work in every single case. What you have to look at why that data is missing in the first place, figure that out. If there is a mechanism, it is missing completely randomly, or because it's missing because maybe while we were recording the data, the database wasn't up to date, and why it was missing, or something. So first you have to figure that, and then use whatever is the best approach. Now, in most cases, you won't know that until actually you create the model. So you would create the model, use different imputing techniques, validate the model, meaning get your R squared value, mean squared value, or evaluate the model, see which imputation method gives you the best or least error, and then use that method. So there is no one fixed answer. It, as always, it depends.
And Sandeep, just to make sure that I'm not missing a magic feature in Power BI that I didn't know about, you said
Mhm.
backward and forward filling in
Yeah.
Power BI.
Hmm.
Can you elaborate a little bit on that?
Yeah, absolutely. So let's go here um, and go to edit query. And let's say I am going to just replace this value with a null value, right? And then if I right click at the top, and then
Oh,
there
the
should
filling.
be,
It's
yeah, the filling. Well, right
right
over
there.
here, fill
Okay,
up or
I
fill
see.
down,
Okay,
right?
so you talk about the Power Query feature. I
Power
also
query feature.
suggested SQL if you have the ability to process that with SQL. Let's say that's in a SQL relational database, something like that. In SQL Server, we have also windowing functions that might help. That
Yeah,
will allow you to get the value from the previous row, something like this. Like in your example, the sensor data,
correct.
that might be one way to, just to assume that the missing value basically is the previous sensor value.
Correct. And
Uh,
that would be the assumption, right? So in the sensor data, for example, it will work. But if it was like
right,
customer data, we cannot
right,
necessarily make that assumption
absolutely.
that, so yeah.
Awesome. And the next question here is that, again, from Pranam, he's asking, are you going to share the presentation? And the best way to do that, just to maybe preempt your answer, is that we don't have, unfortunately, a download location or something like this, since Meetup doesn't have that feature. But if you can put this on your blog,
Yeah,
and if you can send me a link or links, I'm going to include those in the recording description, and users will be able to get it from there.
absolutely. Yeah. So I will definitely do that. And then maybe when you post it on the YouTube as well, include the link,
Yes,
so others can get. And I will be sure to include the Power BI, the Jupyter notebook as well, so others can do the analysis or take a look at it on their own.
got it. And then Esteban was asking, how good is the use of norm? He's asking about DAX functions like norm distribution, Poison.
Yeah.
gamma distribution functions in DAC measures? What are the pros and cons? Is it better to use Python custom visual and create distributions using Python?
So that depends on what your goals are. So the typically what the process is like, for example, let's go back to this. So we have some sort of a distribution over here, right? Um, if you want to create, so there is something called as distribution fitting, meaning if I want to replicate, if I want to take this exact same thing and then put it in Power BI, first I have to know how to replicate this distribution, right? And how do you identify that? If you have a bell curve, you know you can define a bell curve using two things in Power BI as well as Python or anywhere: the mean, the mu, and the standard deviation. And with those two parameters, you can define the bell curve. If you want to do that in Power BI, you can just go to the norm dist function in DAX, or even in Power Query, you have that. And then you can just input your mu and the standard deviation, and then it will create the distribution. So you don't have to use um, any other thing in Power BI. The trouble comes is the problem area is how do you define this distribution in Power BI, right? And for that, you'll have to know a little bit more statistics to how to create fit the distribution first, and then figure out what those parameters are. There are statistical tools, statistical packages in Power BI, in Python, are as well as Jump, SPSS, and SAS, where you can do that. And once you figure out how to do that, the blog that I showed you earlier, where I wrote how you can create this distribution, you will essentially go like, for example, you see that maybe the distribution that fits best is the log normal distribution. And what you will do is you will take this DAX code that I just created with a that creates a distribution with a mean of 80 and a variance of 225, and as simple as take this. So I'll take this, for example, go in Power BI and then create a calculated column on the top of this. Let's see if I can do it right here. Calculated a column right here, and then put it here, put it here, and then just go. Let's give it a try. Yep, and it created a log normal distribution in my case with a mean of 80 and a variance of 225. Let me just mention one really quick thing over here. So the limitation here is that with, like I said earlier, with the what if scenario, this is uniform distribution. It assumes that all the values are possible and they are equal, they have an equal probability, right? How do you assign this distribution, this log normal distribution, to this what if scenario distribution? And the so like I said, I'm in the process of writing a blog on that, but I'll give you a sneak preview. What you would do is you will open this in Tabular Editor. Actually, let's go to Tabular Editor, and I forgot where I created that. So this was in the sales. Okay, so let's go to sales, for example. And actually, let me go here and let's go to sales and let's take this log normal. I'm going to drop it here, and then I create this, right? And if I drop this, now you will see it is list drop down between less than and less than or equal to, right? Whereas when you create a what if scenario, it is a single value slicer. So the way you can convert your usual column into a single value slicer is in Tabular Editor. You can go here, go to tables, sales, my log normal. I'll go to extended properties and I'll add an extended property here that's called parameter metadata. I'll zoom in a bit, okay? And then I'll say version, and that version for that metadata is equal to 0. Let me zoom in a little bit here. So I created an extended property for that column in tabular editor that's called parameter metadata, and the value for that is version, and equal to version is 0. And if I click OK, save it back, and let's say if everything works fine, I should be able to use that now as a single value slicer. There you go. So I have a single value property that popped up here now. I can click on the single value, and now I can use that log normal distribution value as a
And,
probability density function upon.
and what does this property do? Is that documented somewhere, or it's just?
um, so this property is actually, if you go to SQL BI and then single value slicer, let's see, yeah. So this is, if you go to SQL BI, the fine folks, the two Italians, they have written about it. There are different versions. So there is another version where if you wanted to convert the single value, the what if parameter, into a between, there is a way to do that as well. You can edit the metadata, call it version 2, and then there are some other things that you have to do, and you can convert it into a between value as well for a what if parameter.
Great.
But that's essentially what it does.
Awesome. Great. Well, it looks like does anybody have any other questions to wrap this up? Anything else? It looks like I don't see any
Okay, the
more
last thing that I
questions.
will mention is that so if I go over again to my blog, you will see maybe what you will find helpful is maybe take a look at this blog over here, marketing promotion campaign analysis based on time series clustering. And that also uses a similar approach where I don't necessarily use a ton of statistics. All I do is dig deep into the data and then make my observations. So after each thing that I do, I write down what I learned from whatever I did here. So if I plotted this, then I go to the next step. Okay, this is what I'm observing in this plot. So let me dig deeper into it. And then so this logic that I'm talking about, where you don't necessarily need to know all the statistics, but how to follow that flow so that you can create these or obtain these insights from this process. I think this blog explains that very well. So take a look at that.
Awesome. It looks like we don't have any more questions,
Okay.
so we're gonna wrap this up. I put link, guys, in the chat window where actually you will be able, you can download or you can watch the videos from YouTube. Please give me about an hour to get this video from this meeting over there. Again, I apologize for the missing link and starting late tonight. But stay healthy until the next meeting, which is going to be on December 5th. I hope I see you. Those of you who are in Atlanta, I hope I see you in person. Again, this is going to be our first in-person meeting since we stopped a couple of years ago. With that said, Sandeep, thank you so much for doing this again. It was wonderful, actually. Great presentation as usual.
Thank you.
Hopefully you can do another one next year for us.
Absolutely.
Thank you so much. All the
Thank
best,
you.
guys.
Bye-bye.
Bye-bye.
Thank you.
Thanks, everyone.